Good evening, class. Today we're going to look at a video on factoring and solving the difference of sum in squares. Okay. The objective of today's lunch video is to how to use the difference of squares and the sum of squares to factor polynomials. Okay, so some vocab I want to go over tonight for tonight's video is difference, sum, and squares. And probably most of you know this, but difference is subtraction. It's the answer to a subtraction problem. Sum is addition. And squares is the value found by multiplying a number times itself. You know, like 3 times 3 equals 9. 2 times 2 equals 4, and so on. Okay, so when we go to factor something of a difference of squares, we're going to have two things. We're going to have a binomial, which is two terms. We're going to have two terms. And then both of these terms are going to be perfect squares. Both terms are perfect squares. And remember, a square is a number times itself. So you'll have like x squared as one term, x to the fourth, x to the third, x to the sixth, x third times x third, or 9, 25, 16, 36. Those are all squares. Okay, so here's an example. So here we have a difference of perfect squares where a squared is perfect squared, b squared is perfect squared, and we are subtracting. So when we factor this out, you might remember this from our quadratic unit, they factor out into like conjugate pairs. Remember, positive and negative. So this would be the square root of a would be a times a. The square root of b is b, and then you make one a positive and one a negative. And that factors out to be the difference of squares. So for example, we have like x squared minus 16. Again, x squared is a perfect square and 16 is a perfect square, and it's being subtracted, so it's a difference. So this would factor to x minus 4 and x plus 4. They're conjugate pairs. Again, another example would be x squared minus 9 would factor to x minus 3, x plus 3. We would have x to the fourth minus 100. Okay, x to the fourth perfect squared is x squared times x squared. Square root of 100 is minus 10 plus 10. So all of these are a difference of perfect squares, and they can be factored using this formula. So you need to memorize this formula here. Okay, here we're looking at a sum of squares. Now when we have the difference of squares, we could factor this out, this binomial out, and use the conjugate pairs to cancel out. We wouldn't have a middle term. But when we're having a sum, it's difficult to do that. So we kind of have to think about what we would do to solve this. So remember, in our quadratic unit, we would take this and we would set this binomial equal to 0, and we would solve for the x factors. We would subtract 4, and I wind up with x squared equals negative 4, and then we would take the square root of both sides, and we wind up with x equal to plus or minus the square root of negative 4, and knowing that we can't have that negative and 4 is a perfect square, we wind up with is equal to plus or minus 2i. Okay, so we have our conjugate pairs here. Well, we know that I could write this, now I have my plus and minus, which would cancel each other out, so I can come down here and kind of say, okay, now I know that this would factor to x and x, and then I can use my conjugate pairs here, plus 2i minus 2i. Okay, and then we know that when we FOIL this back out, we get x squared times x minus 2i would be negative 2 x2i plus x2i, and then these minus 4i squared, these cancel, and I wind up with x squared minus 4i squared, but I squared is equal to negative 1, so negative 4 times negative 1 becomes x squared plus 4. So now I know, sorry, I didn't know this wasn't on there, that if I did all this math, that anytime I have a sum of squares, like x squared plus 9, I can factor that out to x plus 3i and x minus 3i. So again, sum of perfect squares. If I had x squared plus 25, that would be x plus 5i, x minus 5i. Okay, the conjugate pairs. So we have to keep that in mind. Again, x squared plus 36 would be x plus 6i, x minus 6i. And the conjugate pairs cancel each other out. Alright, so let's look at an example here that we're actually going to solve this polynomial. I have x squared minus 49 equals 0. Okay, so I know I have a difference. I have a binomial, 2 terms, and I look and I see that these are both perfect squares. So I know that I can factor it to using the square root of x squared and then the square root of 49. Make one a positive and one a negative. So that gives me x plus 7 equals 0, x minus 7 equals 0. So I know that x equals 7 and x equals negative 7. So that gives me my two x-intercepts. I know if I was to draw this graph, I'd be here at positive 7, here at negative 7, and my graph would look something like that going through. Okay, so that's what that tells me. Okay. Let's look at another example. Okay, now I have a sum of perfect squares. So I remember now that if I set this equal to 0, that I can write this as the, I would set this equal to x squared equals negative 64 and all in square root. But I know that from my sum that I could write this as x plus 8i times x minus 8i. Set these equal to 0. And I'm going to set x plus 8i equal to 0. X minus 8i equals 0. So I get x equals negative 8i, x equals positive 8i here. Okay, so these are not going to be x-intercepts now, okay, because they won't cross. They're solutions, they're roots, but they're not going to be x-intercepts. So that tells me that if I were to graph this, my y-intercept would be all the way up here at 64, because that's the value, and the graph would be floating up here in space. So it's not going to cross the x-axis. These are my imaginary roots because we don't see them. They have the eyes with them. So this is how you would solve a sum of squares. Alright, so that's it for tonight's video. Make sure you mark any questions, do the completion form at the end of the video, and I'll see you in the morning.